Hi guys, I'd like to give you a brief introduction about pfSense with VirtualBox. So first of all, the introduction. This is for a captive portal for Wi-Fi like Starbucks, and that's already working. And so right now, all we have to do is get ASP.NET login page to validate SL login, and that shouldn't be too difficult. So just a brief layout. The WAN is red, LAN is blue, and mixed is purple, which means it has both WAN and LAN. Okay, so we start with the internet, the red side. This is WAN. We have internet to DSL. Most DSL routers have Wi-Fi connected to it, but in this case we will not be using the Wi-Fi. DSL can also be used as cable. DSL or cable modem will be the same pretty much. So that we have the server. It's a Windows server. You have two physical NIC cards. So one will be used towards WAN for the DSL, and the other one will be used for LAN for the wireless access point. And so the clients will be connected only to the wireless access point, and so they'll actually have no direct connection to the DSL. So on the server it's running VirtualBox, and for the end clients, the Smartlaunch customers, they'll actually be running VirtualBox as a service, so they actually won't see anything that's going on. Everything will be silent from their end. Okay, so on VirtualBox, the way we set this up is we bridge our network interface cards. And so the WAN we call M0, emulated 0. And this is the VM bridge. And on the other one, we set network 2 as, we call it EM1. And this is your LAN network. So WAN, LAN. And from here it starts combining. Okay, so VirtualBox is running pfSense. And we'll have a pre-configured image, which is like 25 megabytes. It's not big at all. It's an ISO. And from command line, we can run VirtualBox image silently with as a service. So pfSense, it's the firewall. It's a software firewall, and it's also a DHCP server. So when clients connect to the wireless access point, which is DHCP off, it'll be passed to the server, virtual machine, pfSense, and then DHCP server will assign it an IP address, DNS, etc. So pfSense, now what? ASP.NET. So when a client logs in, they'll only have very limited internet, which is local, and they'll have to be connected through a captive portal. So like Starbucks Wi-Fi, when you connect, it'll bring you to a Wi-Fi portal, and it'll ask you to log in. Right now there's a default login page. There's a default portal, default cancel, and default log out page that can be customized. All you have to do is just upload it. And then our ASP.NET, we'll make a custom one that talks to our Smartlaunch server. ASP.NET, as it implies, is .NET, so we can easily talk to the Smartlaunch server and have it interact. And the way Smartlaunch talks to pfSense is, well, there's actually several different ways. We could use like a terminal connection or SSH or whatever the easiest way is that .NET supplies for us is the way we'll connect to pfSense, and it's very powerful. I wanted to say quickly about pfSense versus monowall. Monowall is very basic and lightweight, and that's nice, but it's not nice for integration and customization. So with pfSense there's multiple ways to connect remotely, and with monowall there's almost no way to connect remotely unless we dive into the source code, and it's complicated. And so that's why we went with pfSense, because it's broad, there's flexibility, customization options, and multiple ways to connect to it remotely through code. Okay, so this is the physical layout, naming conventions. Let's talk about the network details. So the end customer, actually won't have to do much. The only networking knowledge you'll need to have really is just super basic, how to change the IP address on the DSL or cable modem, pretty much their modem slash router, and their wireless access point. If it's just a DSL, if it's just a modem with no router connected, great, you don't need to change anything. But most modems these days actually are a hybrid of a router. So it's half router, half modem. So in this case, you'll have to log in, change the IP address to 192.168.1.1 by default, and later on we could actually customize it in Smartlaunch to ask for what IP they want to use if they're an advanced user. But for now, this is good because most people use this anyway for the DSL or cable modem. Their modem will be 192.168.1.1. Again, Wi-Fi has to be off for this. Okay, so then network interface 0. So the first one, 192.168.1.anything. I use .25. Just whatever you like for your server. This is just connected to your DSL. And for the gateway, you have to put the DSL, 192.168.1.1. Okay, on the other side, let's start down here. Your Wi-Fi clients, of course, have to be a DHCP. You can connect static, but it'll never get to the captive portal. For the Wi-Fi, for the wireless access point, 192.168.0.2. So this wireless access point is pretty much just a glorified switch. DHCP will be off, and wireless will be on, of course, but all it is just a switch. Things pass through it. WAN access is turned off. And so your other network interface card, if you just saw the 1 pop in there, it was a typo. It's actually 192.168.0.anything. Mine's .25, for example. Jumping back to the wireless access point, make sure it's 192.168.0.2, not .1, because .1 later will be your pfSense router. Okay, jumping down to the VM. So your VirtualBox will have these two bridged IP addresses. So from the network interface up here, from WAN, it'll drop down and bridge as DHCP by default. And we want to keep DHCP because it works with both DSL, with PPPoE, and cable modem. So no matter what, it will have the same settings. This is nice. We want this. So it'll set it to 192.168.1. whatever. It doesn't matter. And this is called EM0. Again, this is WAN. On the LAN side, we have 192.168.0.1. This is static, and we set this on the Smartlaunch side. So the end user won't be able to configure this until way later. But for default, we need to have this. This is pfSense's IP address. If we go to this website, we can actually access the web GUI, which you'll see later. This is called M1, which is the LAN. Okay, so finally we're at pfSense. So pfSense has two IP addresses, as you could probably guess from here. Its WAN address, it's the DHCP one, and its LAN address is the .0.1. Okay, so the first thing that we did, again, the customer won't see any of this. This is all pre-configured from our end. We set the DNS 888.88.44 as a secondary. So what is this? This is the Google public DNS, meaning it's global. It doesn't matter who connects to it. This DNS will always be correct and always probably be the best, actually. Right now we have block private networks off, and by default it's on. We turned it off. Captive portal's on. By default it's off. And that's pretty much it. Everything else, the default settings will do for now. And everything's still a work in progress, but from what I can tell, everything seems to be working with just these main settings universally. I personally haven't tested it with cable modem, but it seems like it would work. I think the only time it would have an issue is maybe if there was a static IP for DSL, but that's pretty rare. Okay, moving on. Captive Portal is ASP.NET based, or HTML5, or whatever we want to do. But if we want to interface with the Smartlaunch server, then ASP.NET is probably the best way to go. An alternative would be make an HTML5 site and have everything in XML. And so XML could, we could pull everything from XML, but that's unnecessary, I feel. So what we have here, this is pulled from actually the pfSense Captive Portal settings page. So we have the logout window turned on. That way it'll say click here to log out. They actually have a log out button. That way if they're idle, they're not losing time. This is optional. You can turn it on or off. And we have 3 customized pages that we can upload and replace. So we'll have some generic pages. Later on, people will be able to upload their own for advanced users. But for now, we'll have our own Smartlaunch login page. We have the portal, authentication error page, and logout page. We can customize all 3 of these. And if we have it with ASP.NET, that's pretty powerful. So of course, there'll be a button that says login. It'll call the Smartlaunch code. It'll ask, is the username and password right, etc., the usual login. And if it is right, then they'll be logged in. And when they run out of time, we can trigger an event to connect to pfSense through terminal or SSH, or again whatever is the best method of connecting, and we can force a logout on this user. And after they're verified through the Captive Portal, they get internet. Now I jump back to the first page. We have some notes. Physical equipment required. They'll be required to have a cable or DSL with direct access to the internet and WAN, 2 physical NIC cards, and a wireless access point. And to go into detail, the cable or DSL, if it's a DSL router, it has to be put in bridge mode. Sometimes some DSL routers will support bridge mode and normal connections. So what's suggested is to just try it, and if it doesn't work, then you probably have to log into the DSL router and turn on bridge mode. So this is the only thing that might be a little complicated, but even if we coded it from scratch, then they would still have to do this for the Captive Portal. Most cafe owners will have cable modem and not DSL anyway, since DSL is duplex, usually. Let's see. DHCP on or off are both okay on the DSL or cable, because you can connect the physical PCs, and that's okay. Then they won't be required to connect through the Captive Portal. So on your 2 physical NIC cards, you probably already have at least one. You can buy a second one for 10 or 20 bucks. Really cheap. I've seen some NIC cards where it comes with 2 in 1, but you probably already have one already. And so something optional for later. I want to say the Wi-Fi router is not required. It doesn't have to be a full router is what I mean. You can just have a Wi-Fi switch, because DHCP is off and there's no WAN connection. All it is just a simple local LAN connection, but it has, it's a Wi-Fi access point. One thing I've discovered is later we can experiment with virtual router for optional server broadcasted Wi-Fi, because it actually is working with pfSense, but it's a work in progress. So by using Microsoft's virtual Wi-Fi mini port, we can actually broadcast Wi-Fi from the server as an access point. But that's all later. Anyway, ask me if you have any questions.